In this video, I solve a numerical question on stratified random sampling. But if you are new on my channel Statisticians Club, please subscribe the channel. Here is the statement of question. Suppose a population of capital N, which is population size is 9, is stratified into 3 strata with following measurements. Stratum 1, x11, x12, 2, x13, 4. Stratum 2nd, x21, 6, x22, 8. Stratum 3rd, x31, 1, 11, x32, 15, x33, 16, x34, 19. So stratum 1 constitutes 3 observations, stratum 2nd has 2 observations, and stratum 3rd has 4 observations. What we want to find? If 2 measurements are drawn from each stratum, we draw 2 measurements from each stratum, 2 measurements from stratum 1, 2 measurements from stratum 2, and 2 measurements from stratum 3. State how many samples of size 6 could be chosen from the population. Our question is how many samples we choose if we draw 2 samples from each stratum. Total number of sample size will be 6, means 2 sample here, 2 here, and 2 from stratum 3. So the total number of sample size is 6. And list these samples and then compute mean of these samples. So these are 2 tasks. First we draw samples by using stratified random sampling, and then list all these samples, and after finally we compute their mean. So now let's start. Solution. The population consists of 3 strata, and from each stratum 2 units are to be selected, and the total sample size will be 6, because if we select 2 samples from each stratum, so the sample size will be 6. So suppose the sampling is without replacement from strata. As you know, for without replacement sampling, we select combination formula to select the capital NC small n to select the samples. If you want to see videos on sampling without replacement and numerical questions solved with sampling without replacement, then you can click the link at the end of video. So 3C2, 3 samples from strata 2nd, capital N is 2 and sample size also 2, 1 sample. And from stratum 3rd, capital N is 4. Capital N is the this population. First sample capital N is 3, 2nd stratum capital N is 2, 3rd stratum capital N is 4, and small n sample size is fixed, as we assume that we draw a sample of 2 units, so its sample size is fixed. 4C2, 6 samples. The possible subsamples from stratum 1 is to be associated with subsample from stratum 2. If we select 3 samples, these are associated with stratum sample size. This is 1 sample, and then these combination finally associated with each possible samples from stratum 3rd. So for association, 3 multiplied by 1 multiplied by 16. So the total number of possible samples are 18 of sample size 6 with 2 measurements from each stratum, because we select 2 samples from each stratum. So first stratum constitute 3 samples. So here is stratum population 1, 2, 4. So its combination will be for 3 samples when sampling is without replacement: 1, 2, 1, 4, 2, 4. As you see, 1, 2, 1, 4, 2, 4. So here is 1, 2. 1, 2 repeats with from stratum 1 we have only single combination, because total number of population consists of 2 units 6 and 8, and we draw only one samples from here, which is 6 8, because we have no more available combinations there. So 1 2 combine with 6 8 and combine with 11 15. The population of stratum third is 11 15 16 and 19. So at stratum third we generate 6 samples. So 6 samples, 11 with 15, 11 16, 11 19. Now we start with 15 15 16, 15 19, and at the end finally we left two elements 16 and 18. So we combine all different combinations according to using sampling without replacement, because in the here we use sampling without replacement. And 1.2 combine with this and with this, because our sample size will constitute of sample size 6. So there is 6 sample size in one, and there is 6 sample size in second, and similar procedure is continued. Next, at next slot our sample is change 1 4. So combine 1 4 with all 6 combinations, 1 4 with 11 15, 1 4 with 11 16, 1 4, and at stratum second because we have only one sample size, so continue with this. At third slot we left with 2 4, because here we have 3 sample, so the third sample is 2 4, and now 2 4 combines with all 6 elements of stratified random sample from stratum third. So 11 15 11 16. On this way we complete our all 18 samples. So our first task is completed. We listed our 18 samples. So we list here 18 sample. Next task is we want to calculate their sample mean. As you know, for computing sample mean, first we add up sample elements and then dividing their total. So adding 1 plus 2 plus 6 plus 8 plus 11 plus 15, the answer is 43, and we divide 43 with 6. 43 divided by 6, answer is 7.17. So at second sample, 1 plus 2 plus 6 plus 8 plus 11 plus 16. So 44 divided by 6, answer is 7.33. And similar procedure continue, and at the end 2 plus 4 plus 6 plus 8 plus 16 plus 19, total is 55, and when we divide 55 by 6, the answer is 9.17. So we complete our task. We listed the all samples according to stratified random sampling without replacement, and then we find the sample mean. If you want to see videos on sampling without replacement, solve question and solve numerical question when sampling is simple random sampling without replacement, objective questions about sampling distribution, allocation of sample size according to stratified random sampling, then click the link in front of your screen. Thanks for watching.